Hello there, programmers, and welcome to our Node.js Tutorial for Beginners. I'm Chris Franklin. So let's go ahead and dive straight in today, shall we? So what is Node.js? That's what we're going to talk about today. We're going to cover this in a couple of stages. First, we're going to talk about high level, what Node.js is and how you can use it. Then we're going to look at NPM, the package.json, as well as how to install Node.js, verify that it's running on your system, and then we're going to build a simple application using raw Node.js. Okay? So, what is Node.js? Well, it's a JavaScript runtime. It's built on top of Google Chrome's V8 engine, and it's built to run on the server, not in your browser. So traditional JavaScript is set to run across a wide variety of browser environments, and it interfaces directly with the browser and the web pages being drawn within the browser. So it's got a lot of functionality built into it to allow you to control where things are displayed or set timers to display events and be able to handle input from the user. Node.js, however, is a server-side scripting language built on top of the same JavaScript runtime. It just has a lot of additional functionality that allows you to do things like working with the operating system and network I/O, so being able to send and receive events over the network. Okay. It's also an asynchronous event-driven version of JavaScript. So standard JavaScript is also asynchronous and event-driven, but this is what really sets it aside from some of the other languages that you can use to write server-side applications. Okay, and because of the way that it's built, it's actually extremely good at building largely scalable networking applications. So things that are heavily reliant on I/O, input-output. So reading things off of the socket as messages come into the server and being able to send messages out over the sockets. And being able to handle communication with other services, with other parts of the application. Anything like that that deals with a lot of reading and writing of data. JavaScript and Node.js specifically excels at that kind of thing. Okay. And it's very good at anything that doesn't require it to block the CPU. So if you're doing anything that's super CPU intensive, JavaScript, Node.js in particular, is not the language you should be using for that. You should be using a language that's really good at sharing the resources of multi-core processors. And so I would steer you away from Node.js if that's what you're looking for. Okay. So what do we mean when we say blocking or non-blocking? Okay. When we talk about blocking, what we're talking about is code that's run synchronously, step by step. We require one step to finish running before we move on to the next one. So we have to wait for every line of code to finish before the next one can even execute. We won't accept additional requests while the code is running. So if we're running a completely blocking synchronous application, that means that if we're listening for events to come over the network while we're processing an event, we can't actually handle another event if we're blocked. Okay. The benefit to doing blocking synchronous code is that it's much easier to follow, it's much easier to reason about, and it's much easier to understand. However, it's got all of those downsides of not allowing you to do high throughput applications. So when we talk about non-blocking, what we mean is that the code is asynchronous. Node.js uses a system of callbacks. It sets timeouts, it comes back, code can start executing, and then when it's done actually performing its execution, it registers itself with the event queue as a callback, and that callback then gets executed on the next processing cycle. And we'll talk about the event loop in just a second, but understand that that's how Node.js does things asynchronously. Okay. The callback will fire after the task is complete. Other code in the same execution block will continue executing. It will get a turn to execute first, though, before the callback is actually called. Okay, so we built all of this on top of what's called the event loop. And if you get heavy into the JavaScript world and the Node.js world, you'll hear a lot about the event loop. So what is this mysterious event loop that we're talking about? So don't get scared by this drawing here, but this is the event loop in a nutshell. Okay, there are a series of steps that get called over and over and over again. We walk through all 6 of these stages and we come back to the beginning again and we start over, and we just call these stages every time we go through. There are actually more than these steps involved, but this will give you a very high level picture of the things that we care about as developers. Okay, so what are these steps? What are we actually doing? Well, the very first step that you're going to run into in the event loop is the timer step. So if you're writing JavaScript code and you use the functions set timeout or set interval, this is what we're talking about. This timers block will actually check to see, have any of my timers expired? And if so, call whatever code was contained within them. When we talk about callbacks, then, we're talking about, as I mentioned before, an asynchronous block of code that has registered a callback for whenever it finishes executing. The callback then has its own step that says, a piece of I/O has happened, it was deferred, now it's time for it to run, let's run it at this stage. The idle stage is something that we don't actually have to deal with. It's an internal part of the event loop, but you do have to know that it is there, and it's something that does get called before the next stage, the polling stage. This is where all new events into the system come into our JavaScript execution. Okay, so if we're running on a server and we're listening over a socket for any incoming connections and any incoming requests, this is where they come into. This is where they actually enter the system. So we have an I/O event that comes in, and then we have a series of handlers. This is almost everything that we're going to do inside of JavaScript happens in here. If there's no events currently in this incoming queue, which it is a queue, it's a long list of all of the things that are waiting to be processed. If there's nothing in this list and there are no timers or callbacks registered with the system, Node.js will actually pause here and wait for any of those things to happen. And if they do, then it will pick back up and start running again. But this is where it sleeps, is right here in the poll. Then we have our check. If we use the function setImmediate, then the callback that was set in that function is invoked at this point. So we call setImmediate from inside of our poll block, and then the next thing we do is we execute whatever that block of code was, instead of going back through the whole loop, checking for timers, and then getting into a standard callback. Okay, and finally the last piece is the close callbacks. These are any of the callbacks that we've registered with our system that are events, something like socket.onClose. It's going to happen at this stage. Okay, now that's a lot of details to go through, especially if you're a beginner, and so you don't have to understand any of this, but what you should know is keep this in the back of your mind and just know this is what's actually happening when you're calling these functions moving forward. Okay, now why do we use Node.js? What is it really good at building? Well, if you're going to build REST APIs, if you're going to build web servers that are back-end services that are going to talk to other services or be talked to from clients and return back just raw data, Node.js excels at this kind of work. Okay? It's also really good at building full-stack services. So if you want to build an entire application, front-end and back-end, you want to build blogs or CMS or social media tools, Node.js is going to excel in those areas as well. But there's other things other than writing servers and web pages that you can do with JavaScript. Because of Node.js, we can run it on our desktops, and we can run them as CLI utilities. So we can write a utility that we run from the command line, and it will actually be JavaScript under the hood. The other thing we can do is we can build on top of frameworks like Electron and the Chrome engine itself. and build entire desktop applications. In fact, a lot of modern applications are built this way that we run on our desktops. Anything that's non-CPU intensive, if it's going to be something that's a CPU intensive task, we don't want to write it in Node, but otherwise it's fair game and it's a fantastic use case for it. Okay, so the next thing we want to talk about is NPM. What is NPM? It is the Node.js Package Manager. This is the tool that gets shipped with Node when you install it that allows you to install all of the modules and other Node.js programs. So if you are using a CLI tool or a utility, like I said in the last slide, you're going to install it with NPM so that it's usable across your entire system. All of the other libraries and modules that you bring into your Node applications are going to be installed through the Node Package Manager. All the modules are installed into a local Node modules folder, unless you use a global flag, at which point it's put into a global bin directory that it can then be accessed by the rest of your system. And those modules, NPM will automatically add them into your package.json file for you. Okay? So what is package.json? That's our project definition file. So the very first thing we're going to do when we create a project is we're going to set up this definition file. It's found in the root of the project. Okay. This is what tells NPM how to set up your project for you. Now, you can use this to define how to even launch your application, how to run other utilities such as loading a database or promoting code to a production environment. You can write a whole bunch of stuff inside of your package.json. There's a lot that it can do in there. But when you create it, you can create it manually if you know the format of the file, or you can use npm init and it'll set up a default one for you. Okay, with that, I think we've learned enough about the theory of what Node.js is, and now it's time to go and actually install it. Alright, so at this point, we're going to go ahead and install Node.js onto our system. So to do that, we go to nodejs.org, and there's a big green button which has the recommended version for installing on your system. So I'm running on Mac OS, and it recommends that I install 14.15.4 LTS. Okay, so you can go ahead and click this button. It'll download the package. Click the button and install it, and everything will be good to go. Now, once you've actually done all of this, you'll walk through a series of steps to answer a few questions, where you want to install it, everything like that. It's a standard installation for Windows and Mac OS users. Okay. Once you've done that, then I want you to go ahead and open up a terminal, and we're going to verify that Node is running and on the system for you. So the way we're going to do that is just type in Node, N-O-D-E. Okay. You hit enter, and you'll be taken to the interpreter. This is also called a REPL. Okay. It's the read eval print loop. Okay, so what this is it's a place for us to be able to execute our Node.js code here and test it out before we actually run it inside of an application. I don't personally find a whole lot of use for it, but a lot of developers, when they're very first getting started, this is a great place to experiment and learn your way around the system. Okay. Now you'll notice that I'm running a slightly older version, 14.8, but when you install this, you'll be running whatever version was recommended on the website. Okay, so you hit Control-C twice, and it'll allow you to exit the REPL and get back to your command line. Then you're going to create a demo application folder somewhere on your system. Wherever you want to do that, I went ahead and created it here. That's my demo app folder. Now you can see this folder itself is actually empty. So what I'm going to do is I'm going to do as I recommended in the slides, and I'm going to say node or npm init. Okay, so we're using the npm tool, the Node package manager, and we're going to initialize a new empty project. So we'll hit init. This will ask us a series of questions. The first thing it's going to ask you is, what do you want to name it? The default is going to be the name of the folder that you're currently sitting in. Okay, so this is fine. I'm going to keep it named demo app. Okay, I just hit enter and it goes on to the next. It'll ask you what version of the application do you want to write. 1.0.0 is fine with me. I'll hit enter. What's the description? You can put a text description however long you want it to be. Go ahead and do that here. I'm going to leave this blank for now. It'll skip it. And then it's going to ask you for your entry point. Now, most applications in Node will be index.js or app.js or something like that. Whatever you want to name your file, you can do that here. If you don't have a preference, leave it as index.js. That's what I'm going to do. I'll hit enter. Then it'll ask you, how do you want to test your application? As you get more and more into Node, you'll want to be able to write tests and verify that your application is semantically correct and does what you expect it to do. And the way to do that is with this test command. Again, we're going to skip this. We'll cover that at a later tutorial. Okay, and then your Git repository. If you initialize it with Git, if you know how to do that, you can put that repository name in here. We didn't do that. We're not going to. Okay, again, hit enter, and it keywords. This is so that if you publish the package out onto the npm registry where all of the modules are registered that you're going to install, keywords are a way for people to be able to find your application. And finally, author. So I'm going to go ahead and put my name, Chris Franklin. Put your name. Please don't put mine because you're not me. All right. And your license, whatever license you feel like doing, if you know anything about software licenses. You hit OK. It asks you, is this everything okay? And you say yes. It'll create this file for you. Okay. Now that our application has created, the next step is to actually spin up a new file and start using that. So if we hit ls, you can see package.json is here. Now I'm going to use Visual Studio Code because that's my preferred editor. You can use whatever text editor you're comfortable using. I prefer anything like VS Code or Sublime or something that is built for programming. Don't use something like Notepad or anything like that because that's just going to make your life very, very difficult. Okay, so I'm going to go ahead and open up VS Code and I'm going to open up in the current directory. You'll see when this starts up, we're at the root of the directory and you can see our package.json in here as we created it. Okay, so you can see what this does. This all got set up for us automatically. And the script section here, we have no tests because we skipped that, but you can see the license type, name, the main entry point, and all of this other information. Okay, so let's go ahead and create another file in here, and we're going to call this index.js. Okay, and we hit enter, and this will load up the file for us. Now we're going to create a really, really dead simple server here, and all we're going to do is just return an OK response whenever someone hits it. We just want to see how this works. Okay, so hopefully you're already familiar with JavaScript a little bit. This isn't going to be completely shocking to you. So we're going to set up a constant of HTTP, and we're going to require a module. Now we don't have to import the module using npm because HTTP, the HTTP module here, is a core module of Node. It comes installed with Node, so when you run it, it's there. Okay, and then I'm going to set up a host name, and I'm going to set that to 127.0.0.1. Now you can do this inline later where I use hostname. You can actually include this and embed this into the function that we're going to use this, but I like to put all of my variables at the top of the file just to make it easy to find. Okay, and then the next thing we're going to do is a new const, and we're going to set up the port, and we're going to set that to port 8000. Okay, port 80 is your default web port, so this is going to be port 8000 so that it's not interfering with port 80. Okay, now we're going to define a server. So this is our web server that we're defining here, and we're going to use the HTTP package and http.createServer. Now you see the reason I like to use VS Code here is because it comes with autocomplete, so this will help me figure out what I'm actually going to be putting in here. So we can say create server, And then we're going to pass in an arrow function. We're going to define a function inline here. It just takes a function as the argument inside of here, and that's the request listener. How are we going to respond to each request? So the request listener takes two arguments, req, the request, and res, the response. Okay. Now you can actually call these request and response if you want to, but that's up to you. Okay. So once you do that, then we're going to use our fat arrow here to pass in context, and we're going to create a code block. So inside of here, this is where we're going to actually handle the request that comes in. There's a lot we can do in here. If you're writing a full-fledged web server, you can take and check what path is appended onto the end of it and route it to different functions based off of that. Or if you're going down another path, you can use something like Express or Koa, which are frameworks that extend the functionality of the base HTTP server and give you the ability to define routes in a much nicer way. But for now, we're just going to take every request that comes into this server and we're going to handle it the same way. So we're going to send a response back to everything. And to send the response, we have to set a couple of things. The first thing we're going to set is the status code. And we're going to set the status code to 200. This is a successful response. Okay, so we're going to say 200 means okay in HTTP language. All right. Then we're going to set a header. Okay. And the reason we do this is so that we can tell whoever hits us what type of data. What type of data they're doing here. I need a parenthesis and not a 9. So let's do content type. So that's the content type header. What type of content are we returning in this response? And the type we're going to return is text / PLAIN. There we go. And so make sure we get all the matching single quotes. So there we go. So we set a new header, content type, text plain. Okay. And then add our semicolon at the end here. And the final thing we want to respond with is actually just end the response. So this is what we call to tell it, I'm done writing to the response. You can take it and process it. And inside of here, we can set a body of what we want to send as the final thing. So let's just say something like response sent. Okay. And you'll see where this shows up here in just a second when we actually look at it. All right. So I go ahead and I close out that block, and the final thing we need to do is call server.listen. Okay, and server.listen takes in the port, which we defined above, and the host name, which we also defined above, and then it takes in a callback function. Okay, so we're going to say, let's pass in the callback. And we're going to open our brackets, and then we're going to say console.log, and we're going to log out that server started on port, and we'll do %s, and we'll do the console.log allows us to format the message, and the way we do that is we use this %s, and then we do a comma here, and we pass in the port. So this will allow us to print out what port are we actually running and listening on. So let's add our final semicolon here, and this is it. This is the entire application. Oh, because I accidentally brought in platform. This is one thing it does. If I bring in os.platform, for instance, I accidentally auto-completed that, so this automatically loads at the top of the file. So if you do that and you're using something like VS Code and it auto-imports things for you, make sure you delete anything that's not being used that gets brought in by accident like that. Okay, so there we go. So now we've got, this is it. It's just 14 lines of code. That's all it requires to actually do this. So how do we actually run this? Well, I'm glad you asked. Come back here to your to your folder, and we can just run node on index. So we can just pass the name of the file. You can add the .js if you want to or not. That's up to you. But once you go ahead and hit enter, you'll see it says server started on port 8000. Now we have two ways we can interact with this. The first is I'm going to go ahead and open up another tab here. Okay. This will create a new window for us, and inside of here I can run curl, and I can run it on localhost 8000. Okay, so we're running on localhost. That's the same as 127.0.0.1. That is the equivalent is localhost, and we're on port 8000. So if I hit enter here, you'll see I get back a text response sent. Okay, and so that's what we're sending here. But let's look at this a little differently here. Let's slide this over. Let's go back in our browser here, and let's open a new window. And inside the browser, let's type in localhost port 8000. Oops, 8000, not 98,000. Alright, and so if we run that on port 8000 and we hit enter now you'll be able to see the same thing here. We're seeing responses sent. But let's go ahead and right click in here and inspect and see what's actually happening inside here. And to inspect, I'm going to go over here to the network tab, and then I'm going to refresh this page. So if I go ahead and hit refresh, you'll see there is a call to localhost here. So if I click on this call, you can see kind of the HTTP request that's being made here. So we're making a GET request to localhost 8000, and we're getting back a status code of 200. As you saw, that's the status code that we set here. And then we're also going to get back, as part of the response, a content type of text plain. And that's the content type we set there. And then if you click over on this tab here, 2 over from the headers tab, you can see the response itself, and the response is response sent. And that's it. That's the basics of setting up and running a Node.js application. There's a lot more that you can build on from here, but this gives you the bare bone basics of what you need to know to get started writing Node applications. Thank you all so much. I look forward to seeing you, and if you enjoyed this and want to see some of my further videos and follow along in this tutorial series, please go ahead and hit that subscribe button down below and smash that like button so that YouTube knows how much you enjoyed it. Alright, thank you so much, and I'll see you later.